Hello everyone, so my name is Shankar and today this video is not about any algorithm or any function writing. It's about introducing myself, telling you about recursion, telling you about DP, dynamic programming, that I use often in my codes. Let's get started. About me, my name is Shankar. I am from Delhi, capital of India, and currently pursuing my engineering degree from National Institute of Technology, Delhi, NITD. About my coding, I'm coding for last 5 years and 3 languages majorly I'm using for this: C++, Java and Python. I have built many projects in Java as an intern. Currently I'm an app developer intern at a company in Faridabad near Delhi, NCR. About recursion. Recursion is a property of a function due to which it calls itself. Now question arises, why we use recursion and how we use recursion? Simple. Suppose I am to calculate factorial of a given number. N factorial can be written as this. Suppose I am to write 6 factorial, then this will be 6 cross 5 cross 3 cross 2 cross 1. This is 6 factorial. And what is 5 factorial? 5 cross 1. Now, we can simply see that 6 factorial is nothing but just 6 cross 5 factorial. Suppose I write a function that will return factorial of a number. So the function will be like this: int factorial. It will take an integer n and will return n cross factorial of n minus 1. Simple. Now, question arrives, when here will be 6, it will call factorial of 5. When here will be 5, it will call factorial of 4, then 3, then 2, then 1, then 0, then minus 1. Factorial is defined for positive terms only. So here will be a constraint. If n is less than equals to 1, then we will return 1. This function is a function for calculating factorial that uses recursion because it's calling itself and using that result to print its ultimate result. Okay, this is the work of a recursive function. Now, 2 things I can notice through this. A recursive function means there will be a statement calling that function again, and there will be a base case to limit the input of function. Okay, so we can say there are 2 things that a recursive function has. First, the statement that calls the function itself, and second thing a recursive function must has is the base case. Now guys, suppose there is a function that is recursive in nature, but it calls itself many times for same value. This means same subproblem is solved many times. Suppose here is a case. Okay, so I'll start with the example of Knapsack problem in which I use dynamic programming. Okay guys, so I'll make you understand how recursive function can call itself many times for same value and how to overcome that issue. And I'll also tell you why that is an issue. Okay, that's when DP, dynamic programming, comes into account. Okay, you guys should check out my Knapsack problem video. I'll put the link in the description below. Please make sure to check out my description. In Knapsack problem, a thief has a bag with carrying capacity C. It has n articles with their weights and their values. Now, thief is to choose articles so that all of them fit into the bag of thief and can provide maximum value. Okay, This is knapsack problem. So the first approach that comes to my mind is brute force. This means I have say 5 articles with weight 2, 5, 1, 3, 4. These are weights and values of these articles or prices of these articles are 15, 14, 10, 45 and 30. Okay, this example is taken from my that video only. So there are 5 articles, n equals to 5, with these weights and these values of prices, and now function returns the maximum profit that I can take out of these articles with this carrying limit and with these weights and values. Okay, so it will return the maximum profit that I can take by taking these two parameters. Okay, these two. So this function has two base cases. First base case is if carrying capacity is 0 or number of articles is 0, then I cannot take any profit out of it because I cannot carry anything, or there is no article, so return 0, no profit can be carried out. If the weight of that last element exceeds the carrying capacity, then return KS knapsack, C and n minus 1. This means I excluded last element and returning the profit with the remaining elements. Okay, now here I can see no element exceeds the carrying capacity, so this case will never work for this example, but for a given example this case may work. Okay, now the last case is that I can carry, I have capacity and articles are there and they do not exceed my carrying capacity limit. No base case is there. Now in this case I'll be calculating all subsets of these articles. I'll limit them to store in this capacity by this, and then I'll be printing the maximum of the profits of each subset. It will return maximum of two cases: the knapsack that included last element, so capacity reduced, and elements also, or I might not be including this element to get maximum profit, so I'll write same capacity but not including this element. Function is over, but there is a problem because I am calling the function all subsets, so number of subsets is 2 raised to n. So this is the complexity of this function, recursive function. But by using dynamic programming, I solved this problem with order of nc. Yes, just order of nc. That's so small than this. So this is the complexity of this function, and if you check out my dynamic programming video, then you will find that this problem can be solved with the order of nc. This is the power of dynamic programming. Now question arrives, can we apply dynamic programming for every recursive function? What are the conditions for applying dynamic programming? Can we solve all functions with dynamic programming? Why do we need recursive function? As a good coder, it's our responsibility to write highly efficient codes So there are three conditions to find whether we can apply dynamic programming to a problem or not. So here are three conditions for any solution that must be satisfied to use DP, dynamic programming. Now, question arrives, what are these conditions and how can we understand them? See, the first condition for using dynamic programming is that the function must be recursive. So this condition was satisfied there. That's why I used dynamic programming in Knapsack problem specified video in the description. Now second thing is, it creates the difference between a recursive function that can use DP or a recursive function that can't use DP. For a function that is recursive in nature and can be turned to dynamic programming function, it must has optimal subproblems. Suppose the knapsack function is there, okay, and it has 5 capacity and 5 articles, suppose. So there are two cases, okay. There might be the article at the last be selected, so capacity reduces and choices reduces. But there is a possibility that we do not select that article, so capacity stays same and choices reduce. Again, we chose last element. So both reduced. We do not chose last element, so one do not change. We chose last element, so this. We do not chose last element, we do not chose last element. This. You must remember, I was using the maximum of these two values and returned in knapsack function. So knapsack function has a statement that calls knapsack function twice. So in this example we can see this function is repeated. This is the problem. We do not want to waste our time in calculating same thing again when we can use that again. So this is the problem that we were facing in the recursive function. And now in knapsack problem with dynamic programming, what we did, we were using dynamic program where we were storing the calculated results in a two-dimensional matrix that can be used further whenever required. This is the advantage of dynamic programming, that makes it order of NC instead of 2 raised to n. So this is optimal subproblems in which we can use same solution many times and save the efficiency. In this, what we are said, that we will start with bottommost case and then move to ultimate case. Now in recursion function we can see that this will return the value when this will be passed to this, and this will be passed to this. This will return the value when this will be passed to this, and this will be passed to this. Similarly, this will return the value when this will be passed to this, and this will be passed to this. So what we are doing exactly, we are going to base and then using those values to get the solution. So we are using bottom to up approach while solving the function. Let me summarize this now. So function must be recursive. This means it should be calling itself. There must be optimal subproblems. This means same function with same parameters is called many times due to many statements of recursion in same function. And thirdly, there should be a bottom to up approach available in the function. If these three conditions are satisfied by a recursive function, then we can use dynamic programming and write it efficiently from exponential order to quadratic order, sometime in linear order as well. You must remember the cadence algorithm. I hope you guys understood what's the meaning of recursive function, what is base case, when we call this, how we call this, what is the condition for using dynamic programming, what is a suboptimal problem, what is recursive, what is bottom to up approach, about me. I hope you get all this. If you like this video, give it a big thumbs up, subscribe to my channel for more such interesting videos. Goodbye.